Okay, I had to pull all these capacitors out of here. They were they had two of them in backwards. One of them was in the right way, and it burnt up, and oh, it's just a mess. So, but I wanted to show you what we got here. These are all 16 microfarad electrolytic capacitors. I checked this first one, and they're old and I'm sure leaky anyway because they've been in wrong. Okay, this one is still testing fine as far as microfarads, 16.03, so it's probably okay. I mean, it would run the set, but you see how it's dropping? Oh, okay, it balanced out. Good. Okay, so this one's all right. We can use it to power the set. This one here, okay, we put the positive on the positive and the negative on the negative. By the way, this is the one that was in right, but it was on the other side of one that was in backwards. So it got destroyed. It's less than half what it's supposed to be because it had way too much reverse voltage from the one next to it that was grounded backwards. So it's bad. Goes in the junk pile. It's got to be replaced. I'll probably put a 22 microfarad capacitor in its place. And this is the final one, another 16. And I will use 22s because 22s is the new standard, and you can go up in capacitance. You can't go, you don't want to go up much, but you can go up a little bit. You know, you can go up as high on this and transformer. You can go up as high as 30 microfarad, 50 microfarad. In fact, the higher you get, the more smoothing you get. But you don't want to go stir crazy over what the specs say. They were still learning back then, and so they always use small capacitors in antique radios. You'll see some that are like number 4 microfarad, 8 microfarad, and you know, later on they started realizing the higher microfarad, the better the smoothing effect. Not only that, they couldn't make them high. They just didn't have the technology that we have today. They couldn't make electrolytics that way. Okay, so this one's not too bad. It's a little high, but it's still within range. You know, and it's like charging down, so we'll see how far it goes. It looks like it's going to balance out right about 16.75. So it's about 16 point, oh, it's dropping some more. So it's a little leaky, but it's okay. It would work. You know, it's not as critical as in the circuit that the wax capacitors are in. This is just a smoothing capacitor for your DC. You get too much leakage, you start getting hum. This one won't hum. It'll be fine. But this one here, that other one was short. So these two could be used to power the unit, and they'll smooth the DC. They'll be fine. DC electrolytics are not bad. What they had is they had one of them positive connected here. They had the ground connected to here and here. They had the other one positive connected here, and they had the ground connected here. And I don't know where those wires go. I need to trace them. Somebody added this wire, the same person who put those capacitors in, probably the same person who put that 25 ohm resistor up there that'll most likely have to be replaced. But I just want to get the unit running. So right now I'm waiting on a rectifier tube to come in. Once that comes in, we'll go ahead and power it up. But we're working just on the power supply at this point. So we're about to work on the power supply. And I'll explain why with the schematic in a minute. But this is what we got. So those were backwards. This one up here was also backwards. In fact, this one was way backwards because the ground on this capacitor is actually chassis ground. And they had the anode going to the chassis ground and the cathode or the negative terminal going to these wires. So they had that one backwards. This one was the only one that was, well, it wasn't in right either because they had it going from here to here when it needed to go from here to ground on the capacitor, which is a floating ground. It's isolated from the chassis. But the ground belongs down here. These two, if you look in there, you can see originally are connected together through a wire that started across them. So those two capacitor grounds connect together. Well, they didn't have them connected together. They had the ground here and the positive down there. And then on this one, they had the ground here and the positive over here. So they had them in series across this line, which I don't know what that was doing. So from here to here, the voltage was backwards or too high and toasted that one. And the others, I don't even know. I don't think they ever got the radio to work. Basically, I think probably started smoking, making noise, and they just shut it off and gave up because they didn't know what they were doing. Anyway, I don't know. But this one was backwards too. So, and a dead giveaway on this one, not only the fact that the case is connected to the chassis, but every one of these capacitors has the ground line marked, connected on one side. That one has got the ground line there, connected right to the chassis, right to the capacitor, and yet they still put the anode there and put it in backwards. So, I don't know. But we'll figure it out, and we'll look at the schematic and go through that. Okay, here you see the capacitors on the schematic, and you notice these are the cathodes, these are the anodes, those are the positive side of the filter capacitors, these are the ground sides. This one is grounded directly to the chassis, so the negative definitely goes to the chassis. That's that one up there. These two go to ground, they connect together. Both the ground sides of the capacitors, or the negative sides of the capacitors, connect together, and they go through a resistor to ground. So they go to ground too, through that resistor. And they were in, well, this one was in backwards from that one, and they were in series and not connected together like they are here. They're just a conglomeration of bad solder joints and capacitors in backwards. In fact, when I was connecting one, the other one just fell off. It wasn't even soldered good. Big globby solder joints everywhere. They were cold joints. I cleaned them up best I can. But I need to verify this wire, and I need to deal with that. But right now, we're going to deal with just the power supply section. So we'll go over that in just a second. Okay, I've got almost half the capacitors done, and I'm working on this board. I wanted to document what we got here, partly. I took the screws out of the can there to get it free. Got a 0.05, a 0.1, and a 0.02 back here. We got this one that somebody put on here that I have to verify. But we also got a varistor, and that sure wasn't original. So that's coming off. It looks like a varistor. It might be a replacement capacitor. I'll check it out. If it's a replacement capacitor and it's the right micro value, I'll leave it there. But otherwise, I'll take it off. It looks like it might be a capacitor. But I'll verify it. And so I just wanted to document that. Then the next thing is these and the coils here and here. You can get these changed just by taking that strip off and change that bad resistor there, and I can just unsolder it until I get these done and then solder it back. And then we got these down here. So that's where I'm at. Okay, here's one of those cool looking capacitors. It may be cool looking, it's a 0.02, but it's not cool in the radio. Look at that, it's leaky, it's still dropping. It's a 0.064. It's supposed to be a 0.02. It's a 0.06. I'm on a nanofarad scale, which is thousandths of a microfarad. So 64 thousandths or 0.064. And you see it's slowly dropping. It's leaky as can be. But check out this capacitor. This is cool. Let me get it off these leads. I just thought it was really interesting looking. You see, it's got that CB, which stands for CMB? It's got an ohm sign in the middle. It looks like, I don't know what that is. CUB, Cub. Anyway, it's a Cornell Doubler Corp, New York, USA, and it's got a patent number of 1,900,000, which means it's really old, 20s or so. I don't know how much of that you can see if the camera's focusing. But what a cool looking capacitor. Try to get it closer to the light, maybe you can see it better. Look at that, there you go. That is just so cool. And then it has the ground end marked with the band. Of course, I put all my capacitors in with the ground side where they belong. 0.02 microfarad, and as we've seen, it was 0.06. So that's what was in there at 200 volts. 0.02 microfarad at 200 volts. What's going in is a 0.02 microfarads at 600 volts. So look at the difference in size. Unreal. And this is only 200 volts. This one's 600 volts. Technology sure changed, but that was really extremely quality for what they had to work with back then. Extreme quality is just amazing. But you can see the wax is deteriorated in it, and that's why it's 3 times what it's supposed to be. So anyway, just thought you might like to see that. Okay, I got this radio recapped all the way down. And except for the electrolytics, which I ordered, I wanted to get the same ones. So I ordered the 16 microfarad 500 volt caps for that. For getting those in there was a bear. I had to take that board completely out to get to those. And same on these coils, I take this connector off to get those down into that coil in there. You can see it going into the coil. And then that one up there. And there's a bare, tight area, but look how much more room there is in here now. So once I get the electrolytics in here, then I'm going to pull out this board, disconnect it, take it out, and check the resistors. But we'll probably fire it up first. As long as this resistor works, it should work. If this resistor is dead here, I might have to change that before I can fire it up. But it should fire. Oh, I got one more I missed. I'll do that now. And then that's it. That'll be all the capacitors. And there were quite a few in this set. Okay, this is Paul. I'm finishing up on this radio, at least the electrical part. You see I have it fully recapped. And had fun trying to figure everything out, but I've got all the capacitors changed. I haven't dealt with this yet. I still got to figure out what to do with that. But I have all the caps changed. I got the electrolytics in. I got the power resistors in there, and you can see them there. And I wire tied them to make bundles top and bottom so they'll stay out of the way. And they needed to be in the same place that the original one is, because the heat rises from these and they get a little warm, and they go right, the heat rises right through that coil hole there. You can see the light when I move my hand, and that's where the heat escapes. I didn't want to move them over here because they would be heating up the bottom of the tube socket. So that's where they needed to be. So I put them in the same place, and I got everything in there. And so I haven't done any tuning or anything. I just now got this finished putting the resistors up in there. So if we turn it on, I've got it set at 70 volts right now. I brought it up slowly on my Variac to do a short test, but I figured you'd want to see this. So, so we'll give it a second to warm up here. And again, I'm not driving it with much voltage, and that's intentional because I haven't done any tuning to it yet. And I don't want to push it until I know we're good to go. So it takes a couple minutes for it to come up. Bring the voltage up a little. Here we go. You know, like I said, I haven't tuned it. I haven't even been around a dial.
She's hard working, dedicated to family, successful in business, and committed to community.
It receives really good. Some of that static is lightning. We got some thunderstorms going on. And it's got fine tuning, which is nice. Yeah, that's some lightning in the area.
Look forward to helping you. Hey, it's Hurricane here. Hurricane Show is now live 90 noon weekdays at 94.3 chill. The best talk shows now at 94.3 FM, WCHO.
Again, I only got it on 80 volts, so you hear that sound, it's awesome. Okay, let's try a different band here. Okay. I don't think I'll get much on shortwave. I'm in a block building here in the basement, and I don't have an antenna. But you can hear it's trying to pull in some stuff. Okay, let's try a different band. Not getting much on that band, not even getting noise. That band's normally dead anyway. But the AM band's doing good. And if I had an antenna, it would get the shortwave. But there you have it. So the next thing now is everything seems to be working here. Gonna go ahead and tune it. We'll work on tuning this radio and getting it playing. And the customer has decided they want an audio input and Bluetooth installed. So we're gonna add Bluetooth to it and put a switch in the back to flip it on and off, or on the cabinet, and this radio will sound great. So anyway, thanks for watching. If you found this video series informative, please consider giving me a thumbs up and we'll go from there. Thank you.